I wanted to do a few examples of exponential equations, exponential growth formulas, and how we can solve them using logarithms like we've talked about in class. So here's a question about depreciation for a car. Suppose you had a car originally valued at $30,000 and it depreciated by 15% each year, which means each year the value of the car goes down by 15%. Now in real life, cars depreciate much more the first year than they do other years, even in terms of percentage. So this is not exactly true, but let's pretend it's close. So the question is, when will it reach down to 10% or $10,000? So here's the formula that you're going to need. And like we've talked about in class, you can set it up with this general formula for the parentheses. And one of those parentheses will be a question mark, which will be the variable we want to figure out. And in this case, that's going to be when. So we're going to need to know t years. And one of the things that's important here is what's the growth, the period that they're talking about. They talk about it depreciates 15% each year. So the growth factor, it's really a decrease factor, but we'll just say growth factor is 1 minus 15% each year, every 1 year. So what we've talked about in class is you want to divide the number of years by the length of each period. In this case, the period is just 1, so we don't really have to do that. But we want to multiply by 85%, right? So each year, you only have 85% of the value that you had the previous year. So the first two parentheses is the start, the initial. And what we want is down the road, we want to know when will it be final or future value. When is it worth only $10,000? So how do we solve that type of thing? Well, we solve it by dividing by 30,000. So we get 1/3 equals 0.85 to the t, because we want to figure out how many times you multiply by 85% to end up with 1/3 of your original value. The way we've described solving that in class is to change the base from 0.85 to 10 to some power. And what we've said is, what is that power? Well, that power is log of 0.85, which is a number that your calculator can spit out, which is the power of 10 you raise to get 0.85. So it's going to be some number, some decimal, so that 10 to that power is the same as 0.85. But it gets it into a common base 10, which is what our calculator can use, and it's much easier. And so now what we want is, we want to know what power of 10 is going to give you 1/3. What power of 10 equals 1/3? Well, that is the log, that's defined to be the log of 1/3 equals that power of 10, which is log of times t, and I'll keep the color straight here, 0.85. So what happens is that power is equal to the log of 1/3, because the log of 1/3 is the power you need to raise 10 to get 1/3. So it's kind of a almost circular thing here. And then you can solve that t ends up being the log of 1/3 over the log of 0.85. And we can solve that on your calculator by saying, what is 1 divided by 3 is that, and I want to take the log of that, and I get negative 0.477. Negative 0.477. And it's negative because you're decreasing. You're going down, your growth factor is less than 1, it's 1/3. So if you're decreasing, your logarithm is going to be negative. And your log of 0.85 is also going to be negative because that's an annual decrease. So what does that say? We get 0.85, and we take the log of that as negative 0.07. So we get negative 0.07, and divide those. 0.47 over 0.07 is 0.477 divided by 0.07 equals 6.8. So it's going to be about 6.8, almost 7 years before your car decreases to a third of its original value. Let's try another one. So compounded interest problem. So suppose you invest $1,000 in an account that compounds interest quarterly. So let's keep that in mind. And it has a periodic rate or an annual percentage rate of 6.5%. What is, and I think I have R and Y switched here. So I apologize for that. Because the rate is what the bank claims is annually they'll give you 6.5%. That's the APR, the annual percentage rate. But when you compound more often than annually, you end up getting a little bit more at the end of a year than 6.5, and that's called the yield, the APY. So what I want to know is what happens here? What's my annual percentage yield? What do I get every year? And when will it double? When will I go from 1,000 to 2,000? So what's the formula you start with? The formula is the amount, is 1,000 times 1 plus, what's our periodic growth rate? Let's figure that out. Well, I get 0.065 every year, but since I'm doing it quarterly, that's my quarterly interest rate. So I have 1 plus that every year, or every quarter. So let me move this down a little bit and give myself some space. I'll multiply by 1 plus 0.065 over 4. How often? Well, what we've said in class is you do t divided by h, and h in our case is 1/4 of a year. How long is a period? A period is 1/4 of a year. Well, what is 1,000 times 1 plus 0.065 over 4 to the t over 1/4? If you divide by 1/4, that's the same as multiplying by 4. And so if you remember, when we first did exponent or compound interest, we kind of talked about there's going to be 4t quarters in t years. We explained that exponent was going to be n times t if you compound the interest n times every year. 4 times t if you compound the interest 4 times a year. Now that we've talked about exponential growth, we're really talking about you divide by the period, which is 1/4 of a year. So we talked about that last week briefly, that formula of saying you always divide by the period ends up being you multiply by the number of periods per year. And so you can get an equation like this, A equals that. So let's do the calculations. What is the annual percentage yield? Annual yield is when t is 1 year. So what do I get? I go from 1,000 times 1 plus 0.065 over 4 to the 1 times 4. In 1 year, I calculate interest 4 times. So I'm going to get that. And what does my calculator tell me that is? 1 plus 0.065, 0.065 divided by 4 is 0.01625. Then I add my 1, and that is my periodic growth factor. And then I want to raise that to the 4th power. And I get 1.0666. 1.0165, was that what that was? Is 1,000, 1.0666. So I end up getting $1,066.60, roughly. I rounded a little bit. But my percentage increase is 6.66% annual APY. Y, annual percentage yield, right? So they offered me 6.5% interest, but because they compounded a little bit more often, at the end of the year, I end up with a little bit more than that. So how do I calculate the last question? When will I have $2,000? When will I double? So how do we solve how long it's going to take for it to double from 1,000 to 2,000? If we're multiplying each time by this, we've got 4t is the number of times we multiply in t years. So we've got 4t as our exponent. And then the idea is we change to the base from this ugly number 1.0165 to 10 to the log of 1.0165, because that's what the logarithm is defined to be. Then we still got this times 4t in the exponent. And now we have 10 raised to this power equals 2, and the logarithm of 2 is defined to be the power. You have to raise 10 to get 2, so that's equal to the power. And we can solve for 4t equals that. And 4t is about 43. So t is about 10.75 years. So we can solve exponential problems using this logarithm form by changing the base to 10. And I hope you can do that a few times and get the feel of it.